Right, so today's video is about the motor, and I was going to go with a Revolt RV160E water-cooled motor, but I didn't like the idea of ordering a motor that comes from Israel for import and it might never get here reasons, so I've got something a bit different. Now this thing's a bit of an unwieldy little thing, or big thing rather. It's not really little, it's like 25 by 20 centimetres and it's quite heavy, it's about 22 kilos. But this thing is not water cooled and it still has a continuous output of 17 kilowatts. And that's probably without the thing getting warm. This is a Mott Energy ME 1507 and it has a maximum output power of 44 kilowatts, which is quite impressive really, considering the size of it. It's like the size of a little 10 kilowatt or even smaller than that motor. And the only problem with this thing is that it has a sine-cosine resolver on the back of it, but what I figured out is if you turn the thing around to start off with, it has this cover on the back. The resolver is under this cover, and what you can do is you can take this off, and the company that makes the resolver is RLS. They also make Hall sensor or UVW commutation encoders, so what I'm going to do is replace the thing in there with the other one, and hopefully it just works and doesn't blow up or anything along those lines, or doesn't ruin the motor or just takes off at 1,000 miles an hour. Hopefully it does none of that and just works. I've already done my usual with everything I build. It's just one of the things that I've got so used to doing over the years is putting braided sleeving on absolutely everything I make. This is no exception. This has some lovely orange braid on it. And the other annoying thing about this motor is, as it's designed for the controller to be mounted this way, so phase what is this, 1 I think? Yeah, 1, 2 and 3. So the controller is mounted with the bolts in that orientation. But of course I have the controller with the bolts in this orientation, like that, which means these two wires are too short. And I've already made some lovely, also covered in braided sleeving, extension cables that are in the bike already. Now there probably won't be much more video of me on the workbench because most of the stuff is in the shed by now, in the bike or on the bike or around the bike or something like that. And the Sevcon controller is already mounted in the bike. It's not bolted down yet though. It's got all the wires attached to it. I need to put a heatsink under that. Yeah, this thing is quite massive. It's got some weight to it, but hopefully, considering that I've seen some people put these things in go-karts and rat rods and small electric cars, so I think this thing will have plenty of power. And in fact, I don't know if many of you know this, but I'm pretty sure that Zero electric motorcycles use this exact motor or something of this type of thing in their first generation of bike, and the newer ones have a motor that looks exactly identical to this, except for that it's branded differently and it has a different output shaft. I mean, try putting a sprocket on a 25mm output shaft. It's not practical. They've got a spline shaft, so what I'm going to have to do is make an adapter that slots on there that I can bolt the sprocket on with probably around about 10 bolts, maybe more, maybe less, or maybe I'll just weld it on. But that means every single time I replace the front sprocket on this thing, I will need to make a new one, which is very impractical. But I mean, you win some and you lose some. You get the advantage of electric acceleration, you get the disadvantage of having to make a new sprocket every time, and the disadvantage of the thing being absolutely massive and heavy. But the speeds this thing's going to go is going to be ridiculous. But I mean, the next thing I'm going to have to do is mount this in the bike, make a sprocket, make a chain tensioner device, because this sits too low in the bike, so I have to bring the chain up off the chain guide, over a sprocket, onto this sprocket, and then back to the wheel. Now what I'm also going to do, which is quite sneaky, because this is going to be a 125 equivalent bike, which means I won't need that much speed, which means what I'm going to do is put a massive sprocket on the rear wheel, because, I mean, they're allowed to go a maximum of 60 miles an hour. They've never stated how much torque the thing can have, so I think I'm going to make up for speed and acceleration. I mean, with these things you get 0 to 60 in 3 or so seconds, so this could be quite good, potentially. But mounting this is not going to be fun, considering that it's got 4 massive holes in the front for mounting. I think those are M12 screws. So I have to make a plate that fits on the front of this, and then somehow mount that in the bike. I'll probably make a little rest, because it's got 2 flats on it. I'll probably make some sort of rest on either side as a vibration mount, so that it doesn't sort of vibrate just as much, and put some damping on there as well maybe, so it's a bit quieter. I was also thinking of belt drive rather than chain drive, because chain drive's loud, it's dirty, it's messy, and it's just not as good as belt drive. But I thought for belt drive I'm going to need to get special pulleys and belts, and no thank you, because chains and sprockets are very cheap, so I think I'll go with that. Yeah, this is probably going to be quite a boring video, as it's already about 10 minutes long and all you can see is the front of a motor. So what I think I'm going to do is cut it here and make the next video about the motor running, I think, because what I have to do is replace the encoder in the back, as I said, or resolver or whatever it is, and put a new plug on there, because this is like some expensive, really expensive plug on this. And these are, by the looks of it, really nice, but they're also only 8 pins. Now, I'm going to need more than 8. Actually, I might get away with that, to be honest. I might get away with that, but what I think I'll do is I'll put one of these generic waterproof connectors on it, as these aren't quite as good as that, because that's like professional grade. These are sort of eBay, cheapy Chinesium grade, but they're still, if I didn't drop it, somewhat waterproof. Hang on a minute, grab that. Right, there we go. But I think one of them on the end, well, it's going to need a 5-pin one for the hall sensors, and then another 2-pin one for the temperature sensor, because you can't get 8-pin ones of these. So I might end up using this. I might end up using this. I don't know yet. But that's it for today, and hopefully by the end of the week I'll have another video out that's about the thing going, and that's going to be fun to watch. But I don't know if I'll be able to, because I don't have any means of really powering it except for some bench power supplies, and I think to power something of this size, even free running, it's going to need at least like 5 or so amps. So I'm going to need to figure that out. I might just use my big industrial 12-volt supply and boost that up to 100. So I mean, I've got access to 24 volts at about 250 amps. So I might just boost that up with a couple of booster modules and then whack that on the Sevcon. That has worked before. Anyway, that is it for today.